Every time you click, every time you share, you're leaving behind a tiny digital breadcrumb, a little piece of you, sent out into the world. But have you ever stopped to wonder what actually happens to it after you hit send? You know, we tend to think of data security as this super complex wall of code, something for the tech wizards. Well, today, we're going to peek behind that wall. We're going to follow the secret life of our data on its hidden journey. And that's really the core question, isn't it? The answer, well, it isn't some single destination. It's a journey. Your data doesn't just land in one spot and stay there. It lives a whole life, with a beginning, a middle, and believe it or not, an end. And if you can understand that life cycle, you can really understand how it's all protected.
So, this secret life, it starts the second the data is created. First, someone has to identify it, figure out what it is, kind of like putting an X on a treasure map. Then it gets protected, like it's the crown jewels in a high-security vault. But here's the part we almost never think about. For data to be truly secure, its life has to end. It has to be safely and permanently destroyed.
So let's start at the beginning of that journey.
What's the very first step? It's asking one simple question. What is this stuff actually worth? I mean, think about it. You wouldn't guard a paper cup with the same intensity as a bar of solid gold, right? It's the same in the digital world. The first, most crucial step to protecting data is figuring out just how valuable it really is. And to figure out that value, security pros use this really powerful framework. They call it the 5 No's. And it looks simple, but it cuts right through all the complexity. You've got to know its value. You've got to know who can touch it, where it physically lives, who's supposed to be guarding it, and, this is the big one, how good of a job are those guards actually doing? Everything, and I mean everything, flows from that first question of value.
So when we talk about sensitive data, what are we even talking about? Well, it's a few key things. It's your PII, your personally identifiable information, your name, your address, the stuff that makes you, you. It's your PHI, your protected health information, the private details about your health. And for a company, it's their proprietary data, the secret sauce, the customer list, the very thing that gives them their competitive edge. This is the stuff that gets the gold bar level of protection.
And this is how that value gets made official. Organizations create these classification schemes. And what's really cool is they pretty much mirror the stuff we all know from spy movies. The government's top secret is basically a corporation's confidential. What a company calls private is kind of like the government's secret. It's the exact same logic, just with different labels. And this one act, just labeling the data, determines everything that happens to it next.
Okay, so the data has a value, it has a label. Now it's time to actually protect it. This is the part of its life where we build the digital fortress, where we bring out the locks and keys to keep it safe.
But here's where it gets really tricky. Data is a moving target. It's not like a gold bar that just sits in a vault. It's constantly flowing, constantly changing, which makes protecting it a whole lot harder.
Professionals break this problem down into 3 states. First, you have data at rest. That's a file just sitting on a hard drive. Think of a stolen laptop. Then there's data in transit. That's an email flying across the internet, maybe over some sketchy public Wi-Fi. And then you have the trickiest one, data in use. That's when it's live in your computer's memory, being worked on by an app. Each one of those states is vulnerable in a totally different way and needs its own kind of lock.
So, how in the world do you protect something that's constantly on the move, constantly changing form? How do you lock it down when it's resting, when it's flying across the network, and when it's being used, all at the same time?
The answer lies in something that's both ancient and totally futuristic: cryptography. It's basically the art of secret writing, but supercharged with some seriously complex math. It takes our data and just scrambles it into complete gibberish for anyone who doesn't have the secret key. This is the universal tool that protects data everywhere, making sure it stays confidential and that nobody has tampered with it. Now, encryption comes in 2 main flavors. You've got symmetric, which is like a simple lockbox, where everyone on the team has the same key. It's super fast, perfect for locking up huge amounts of data. Then you have asymmetric. This is more like a secure mailbox. Anyone can drop a letter in through the public slot, but only you have the private key to open it up and read it. It's slower, but way more secure for sending secret things. And here's the brilliant part. Modern systems use both. They use the slow, ultra-secure one to safely share the key for the fast one.
It's truly the best of both worlds.
But a digital fortress isn't meant to last forever, because every data lifecycle, as we said, must have an end. Just keeping old data around is a huge risk. So the final and maybe most important act of protection is actually destruction.
This is why organizations live and die by these things called data retention policies. Every single piece of old data they're holding onto is a potential liability. It's a target for hackers or a legal nightmare just waiting to happen. So they have these strict timelines. Data is active for a bit, then it goes into an archive for legal reasons, and then finally it hits this non-negotiable end-of-life date. It gets scheduled for destruction.
So how do you actually destroy digital data for good? Well, one way is just pure brute force, degaussing. You take a hard drive or a tape and you blast it with an incredibly powerful magnetic field. It is the digital equivalent of turning a document into atomic dust. The ones and zeros are so completely scrambled that there is absolutely no chance of ever getting them back.
But there's an even more elegant, almost surgical method called crypto shredding. Remember how we used encryption to lock the data up? Well, instead of trying to hunt down and destroy every single copy of that data, which can be really hard, you just destroy the one thing that makes it readable, the encryption key. The scrambled data might still exist somewhere out there, but it's just garbage now. It's permanently unreadable. You've effectively erased it by just throwing away the key. It's absolutely brilliant.
All right, so we've been following the life of a single piece of data from birth to death. Now let's zoom out and look at the big picture, the architect's grand plan. These are the high-level principles that are used to design the entire secure system that all of our data lives inside.
See, great security isn't about just reacting to attacks. It's all about proactive design. Smart architects build their systems on a foundation of core principles, things like zero trust, which basically means assume everyone and everything is a threat until it's proven otherwise. Or fail securely, the idea that if something breaks, it should lock down tight, not fail wide open and spill all its secrets. These aren't just rules, they're a philosophy. It's about being paranoid by design to build a truly strong digital fortress.
And these philosophies get turned into formal models. A classic example is the Bell-LaPadula model, which came from the military. It's built on two really simple but incredibly powerful rules. First, no read-up. Someone with secret clearance can't just read a top-secret file. That makes perfect sense. But the second one is no write-down. This means someone with top-secret access can't copy that info into a less secure, secret-level document. With just those two simple rules, the model prevents both spying and accidental leaks across a massive system.
So, there you have it, the secret life of our data. We've seen how it's valued like treasure, locked down with incredible codes, and even given a secure end of life. It's all part of this hidden, complex architecture designed to protect those digital breadcrumbs we leave everywhere we go. Which really just leaves us with one final thought. In a world that is completely built on data, knowing how intricate and valuable this secret life is, are the vaults we're entrusting with it every single day truly strong enough